What's the difference between a register and FIFO?
Register is a 8 bit or a 16 bit in one horizontal row. Okay,
Okay.
you can't store a heavy amount of data in a register.
And that is according to capacity, but characteristic. What's the characteristic difference between these?
That is 2-dimensional memory.
Okay.
Okay, your register is 1-dimensional, you can say.
So FIFO is 2-dimensional.
You can say. You can store in length also, in breadth also. It's having length, breadth also, right? It all depend upon depth. Register you can't use. Suppose there is a bulky traffic.
This is like matrix, like storage.
Matrix.
Yeah, that is also a 2-dimensional.
Okay. Okay.
Not one column.
Okay.
Matrix.
Okay.
Matrix like storage in Fifo. We are saying.
No, you know memory, how memory looks. Memory. First byte will go here. Second byte will go here. Suppose 0 to 15. So it will store like this. Okay, you can't store the same data in registers. If you want to store the same data in register, you will take more space. So you are telling you will going and taking register. Okay, so in that case, what all the signals associated with the registers? Load, enable, then in, out. How many ports are coming? Okay, if only 8-bit data is there, no problem. You can take data in here and keep it here. But not data. Control signals you can keep in register sometime. Okay, control information, data related information. Okay, you take a example of USB. USB, what is the control? PID, address. These type of information you keep in registers. But when data will come, which is 4096 bytes, in that case, you can't. If you will use 4096 registers, means it's not possible. It's not healthy. Instead of that, put that thing in this memory for mass storage. Okay, FIFO will tell how to access this memory. Okay, so here one logic will come, here one logic will come. No, this is memory. Okay, this is control logic, this is control, whole is FIFO. Okay, so this control logic will tell how to write in memory, and this control logic will tell how to read a memory. So that is FIFO. Okay. Characteristic difference means what exactly you are looking for? Difference.
Like why FIFO is different from register? We can. What's the basic purpose of FIFO then? If it's merely shifting data, then we
It's
can
not
shift
shifting data. Yeah? We are not shifting data.
Then what FIFO is used for?
We are synchronizing two clock domains. When we are passing a data from one clock domain to another clock domain, you can't use registers, shift registers, or you were telling.
Okay.
In that case, your register will work at which clock?
So what extra feature is there in FIFO that is going to synchronize that?
There are extra features, I will tell you. But what is there in shift register? You can use that thing. Suppose two clock domains are there.
No, I thought as if it's mere used to transport data from one module to other.
No, it's not merely. If you are using that, then you can go with memory also, right?
Yeah.
Then why you are not using memory? Why you are putting extra burden and creating that thing as FIFO? FIFO is also memory, right? If you memory with extra control logic, you can also use memory. Then why you are using that extra control logic? That is a question.
In one clock domain to another clock domain, we are passing data.
Okay.
By using a FIFO.
Okay.
Why we go for a shift register?
Why we
go for a shift register?
Will not go for shift register, yeah. Why we are not going for shift register? Okay, I will ask you one question. If you answer that question, then it's okay. This two clock domain, okay, 30 megahertz, 40 megahertz. Now you are using this shift register. Okay, this shift register will work at what frequency? Tell me whether it should work at 30 megahertz or 40 megahertz.
Depend on the clock frequency.
No, you tell. One is at 30 megahertz you want to write, and one at 40 megahertz you want to read. What is the clock frequency of this register? So you can't use, right? No, what clock? If you guess, means what clock you will assume?
13.
Why?
first we can use this clock.
So this means that definitely there should some extra logic will come, right? That will synchronize this with respect to 30 megahertz and fill the data. Definitely here some extra logic will come. That will synchronize this with respect to this shift register. Okay. So you cannot use a simple shift register which is working at 1 clock frequency. You have to use some extra logic. Okay. So that is the concept. You can't use shift register which is working at 1 clock frequency. So you cannot use. Okay. And second thing is, if it is a bursty traffic, okay, in that case you can't go with shift register. Okay, during that time you have to go with mass storage device. Okay, so either you can go with FIFO and you can go with any other synchronizing technique. Okay, but my question was, why we are not using memory here? Again, same problem. At what frequency you are going to write inside this memory? Nobody will tell. Okay, so that is a problem. So by
We are using the FIFO in same place.
yeah, we are going to use FIFO in same place. So definitely inside FIFO there is some extra logic that will synchronize this clock domain with this clock memory, and
What
this
is the extra logic?
no, that we'll see how we are synchronizing that thing. That will come in FIFO.
Means that memory is not independent of clock.
Not independent of.
Since memory is a neutral one,
Okay.
it's okay that one domain is writing in it at the speed of 30 megahertz.
Okay.
And it's also okay that one domain is extracting data from it at 40 megahertz.
Okay, right.
So what's the need of synchronizing in memory? We can use memory now. Since we are passing data from 30 domain